So, today we're going to talk about roadway noise barrier design, written by Ranveer Dambe. There has been a trend of increasing traffic noise due to city expansion and urbanization. A study conducted by WHO found that 40% of the population in the EU is exposed to sound pressure levels ranging from 75 dBA to 80 dBA. Prolonged exposure to loud noises can cause hearing loss and damage to the ears. Therefore, an effective solution is needed to mitigate these issues. We need to be careful and make sure people's hearing stay intact in urban areas and areas where a lot of noise and sound is created to help increase the standard of living. So, a noise barrier is one solution to this problem. It is basically a wall that reduces or diverts the sound coming from road traffic, and the amount of noise reduction or attenuation created by a barrier is called the insertion loss. The formulas on the right show that this particular noise barrier that is placed 12 meters from the road and 15 meters from the neighborhood will reduce the sound levels by about 20 decibels, which is a really large amount. Remember that decibels are a logarithmic scale, so an increment from 20 to 21 decibels is actually 10 times as loud as the previous one. The diagram also shows how we go about doing this calculation and calculating N. So this formula can be a general formula that is followed in different cases and situations around the world, because this design of a noise barrier is the main design that we use. Excuse me, I think there's a problem with moving forward to the next slide. Give me a moment. Alright, there we go. So, noise barrier design. The location needs to be taken into careful consideration. The design and type of barrier will need to be changed according to the local environment, since each case will require different attenuations and will induce different restrictions like height and cost. Now, the source on the left means that the highway is at a higher elevation than the neighborhood, which is the receiver. Therefore, a small barrier should be sufficient. It'll block all the noise that needs to be blocked. On the right side, however, our source is at the bottom of the valley and the receiver is at the top. So we either need a really large barrier, which is very expensive, and in this case, the barrier may not be effective and may have to be placed really close to the source. So the position and height and cost are very important considerations that need to be taken into account. Types of sound barriers. So in this diagram on the right, we see a gray cinder block exterior with an interior that can be stuffed with any material. These materials are usually porous and densely packed. The outside is covered with a vegetation, which gives it a more appealing look to people driving by. They may not even notice that there's a noise barrier. Now, we also have certain natural vegetation barriers, referred to as green belts, where there are just trees and shrubs and bushes lined up continuously for the entire length of the road. And you can use natural barriers to reduce the noise pollution. We also have combined barriers, which means you basically have a solid wall and a green belt running parallel to it. So you need this construction on either side of the highway, depending on where you want to block the noise. And it is a very effective way of reducing the amount of noise emanating from a certain roadway. Natural vegetation barriers, if you purely use the natural vegetation, it may not be as effective because vegetations tend to have small air gaps between them. This image shows types of solid barriers. Right, the most common is the concrete barrier. These are solid walls, and usually mix concrete and wood fibers and use those as fillings. These can be precast, so the installation time is reduced. On the right side, we have wood barriers. They're made out of treated wood, but even though they are treated, they're rarely used nowadays due to durability issues. Wood tends to warp and lose color over time, and the warping can cause the wall to lean, which might make it completely fall over. So in most cases, people would use concrete barriers over wood barriers, unless there's a particular aesthetic appeal that they're trying to achieve with getting a wood barrier. Concrete barriers give a more industrial look, so may not be favored in some high-level neighborhoods, and the requirements have to be seen according to the situation. This slide talks about how we can reuse certain types of materials to make it more eco-friendly or environmentally friendly. So here we have rubber tires that are crushed into small granules and compacted together. They're lightweight and have very similar acoustic properties to regular concrete barriers, so they can still be used effectively. Another way is to use coal bottom ash in a concrete noise barrier, which is basically 80% bottom ash and 20% concrete. And this has a much higher insertion loss due to porosity, so in certain cases reusing the materials can be way better and more cost effective because it's less energy intensive to reuse a material that we already have than to produce a completely new material. Now, the recycled tires are not a very common way of building noise barriers, but we hope to, or studies say that they hope to increase the amount of population that uses these reusable materials. Now here we're going to talk about different sound barrier geometries. A change in geometry basically changes the way that the sound waves interact with the wall. So we have a few examples of T-shaped barriers, the middle image on the right. And the barrier increases the effective height as shown in the diagram. It is a cheaper alternative to building taller because it gives the same insertion loss and is more cost effective than making a structure a meter or two taller. The bottom right shows an absorbing edge barrier, which basically means when sound barriers hit the different chambers of the fins, they bounce all over and scramble, and they prevent noise from leaking or propagating to the other side of the wall. The disadvantage is that they tend to have more complex geometries, so the installation procedures need to be more careful, and that means it's more expensive. Here we have longitudinal profiled edge barriers. These barriers are spikes that are there at the top edge to increase destructive interference of sound waves coming from the roads. It basically interferes with how the waves interact and makes it more effective. The bottom shows random edge barriers, and these have a very jagged shape to change the trajectory of the sound. They are only effective in higher frequency waves, so used near factories and other such equipment. Now we have enclosure type barriers. So a tunnel acts like a fully enclosed sound barrier. Even though it's an effective method to block sound, it is expensive to implement and causes the buildup of sound. There are also ventilation issues to consider. The images at the bottom show different types of semi or fully enclosed barriers. We usually use a semi-enclosure because it's more effective. So here we have a sound barrier. This one's made by Duracell, and it's very popular in southern Ontario. They're the biggest manufacturer, and you can see this along the Easy Row Expressway, and they can be seen on the 401 near South Windsor. North American barriers are more likely to be made up of different materials, using composite ones or having double wall barriers. European ones are more likely to be more aesthetic and have more compact shapes, which means they're more difficult to set up, but can fit installed and be unseen. So there's a difference in the way different cultures and different regions go about making their noise barriers, and that also needs to be taken account. Well, in conclusion, hopefully our presentation has given you some insight into how we analyze and design noise barriers, the different design options that we have, the different material options, and the overall consideration needed when looking into how sound is absorbed or deflected by the highway noise pollution. Noise pollution is a very serious problem, and especially in the large metropolitan areas, you're bombarded by sound day and night. So considering this is going to be very important, and a careful look needs to be taken. Alright, does anybody have any questions?
Hi, thanks for this presentation. I have a question for you regarding the materials used. So, you mentioned earlier that rubber can be used to make these sound barriers, but my question to you is in particularly hot and tropical countries, would the rubber not burn and emit harmful gases? And I mean, would it not essentially become a hazard to the overall neighborhood where it's used?
Okay, so yes, when rubber is exposed to heat or to high heat, it can make toxic fumes. But as you can see in this diagram, we have the concrete exterior and we have hollow interiors. So you can fill the interiors with the rubber material, and if it's sealed properly, it should not be much of a hazard to the environment. But yes, careful consideration does need to be taken. People don't use rubber as much as we'd like, but
So if it is not used, and we should be using it because we can then recycle it. So I mean, I sense that this might be a better filler. What do you think about that?
I mean, it has similar acoustic properties to concrete, so I do agree that it should be used. Now, we do need to take into consideration different tolerances in manufacturing techniques around the world. If care is taken and people meet the proper standards, we definitely should be pushing to reuse tires as an effective material.
Have there been any studies that have been conducted that compare the use of a natural sound barrier versus a man-made sound barrier, or like so let's say trees versus whatever a man-made sound barrier?
Yes, if we have natural vegetation, the they're really good at scrambling the sound, at dissipating the sound. But at the end of the day,
Mm-hmm.
they do have some gaps in them, and that means it cannot be a perfect noise barrier. And therefore, in certain applications, a thick wall needs to be considered. Yeah, as you can see over here, this fin design basically scrambles the noise. So trees and vegetation do the same thing, and it's good for higher frequencies. And should be used in those applications, or for where you don't need to block a lot of sound.
Okay, I think I have all my answers.
Alright, well, thank you very much for attending this presentation, and I hope to see you guys sometime soon.
Bye bye.